Hello, Pre-Calc Honors kids. This is Miss LaFour, and today you're looking at Lesson 2, Proving Trigonometric Identities. So notice on this first page we have a lot of guidelines that we use to verify trig identities. And you need to go through these and kind of recognize them. Like you always want to pick one side to work with and get it to be like the other side. You're not going to work on both sides at the same time. You want to choose probably the more complicated side, and if you choose a side and it doesn't work, then it's not getting there. Maybe try a different method or something like that, or you could potentially try the other side, but there's just different options. Now notice that you could change everything in terms to be in sine and cosine. You can look over algebraic operations you can perform. You can recognize, well, you need to recognize the trig functions and know those and identify, like if you see the squares, you need to think about the Pythagorean properties, all of that. So just keep looking at the answer. Where are you going? How are you going to get there? So this is a game of thinking. And then if you don't get there, sometimes you have to try something else. If you go one path and you don't get there, try again. So just keep going. You will eventually get it. So notice on this first one, we are proving this algebraic identity. We are not actually doing anything with trig. They're just kind of showing you this to make sure that you can handle just what we're doing basically. So notice here we have this identity, and there's multiple ways you can do it. Obviously, this side is more complicated than the other. So that's the side I'm going to work with. I'm going to work with the left. And there's multiple ways we can do this. We could get a common denominator and add these together. But I think probably the easier way is that I'm recognizing x squared minus 1 is a pattern. So if I factor that, that is x plus 1 times x minus 1. And notice that if I factor both of these, I can simplify it and it makes it so much easier. So notice that once we factor, this binomial can cancel with this one, straight on top and bottom. Notice I am not canceling across a subtraction sign because you cannot do that. And then on this one, these two can cancel. So I'm left with x plus 1 minus x minus 1. So that's x plus 1 minus x plus 1, which is just 2. And now that I've gotten to the thing I want to get to, then I know I am done. That is actually how you would prove an identity. Now notice on example 2, we're actually using a trig one. We have to work with the left side, because it's obviously more complicated here, okay, because this is more than just that one. So on this one, the first thing I'm noticing is that I have two terms. So I am going to find a common denominator, which is going to be cosine squared. So I can add that together. Notice the first fraction stays the same. Second fraction, I had to multiply the denominator by cosine squared, so I got to multiply the numerator by cosine squared. So that would give me, let's see, that'd be 1 minus cosine squared beta over our common denominator. And at this point, I'm hoping that you will recognize that this whole piece right here is an identity. Okay, think of your Pythagorean identities here. That top piece is equal to sine squared beta. Now, if you don't know the identities, this is going to be extremely difficult. And then, of course, sine over cosine is tangent, so this is tangent squared beta, which is exactly where we want to go. And we got what we needed to, so we're done. All right, so let's look at example 3. Tangent x plus cotangent x equals secant x times cosecant x. Okay, I'm choosing to work with this side because it's easier to go from addition to multiplying than multiplying to addition. So let's see, tangent, cotangent. Let's write it as sine and cosine. So sine x over cosine x plus cosine x over sine x. Now what can we do? Oh, let's just add them together. So that means we need a common denominator. And remember, a common denominator, you just multiply the two denominators together. Okay, so it's cosine x times sine x. So on the first fraction, let's see, I had to multiply by sine x on the bottom. So I need to multiply the top by sine x, so that gives me sine squared x. On the second fraction, I had to multiply by cosine. So times cosine on the top would give me cosine squared x. And that again, right there, that piece is an identity. So this is 1 over cosine x sine x. Oh, look, that gives me right where I need to go. If I do the reciprocal of both of those, I get secant x cosecant x. And voila, I am done. I got the part I needed. All right, let's look at the next one. Example 4. This one says match it. So that means my answer to this thing here is either going to be A or it's going to be B. I don't know. So I need to figure it out. Well, the only thing I know to do would be to add these together and get a common denominator. All right, so my common denominator is going to be secant x minus 1 times secant x plus 1. So that means on the first fraction, I'm multiplying by secant x plus 1. So 1 times secant x plus 1. And then I've got, for the second fraction, 1 times, let's see, that would be secant x minus 1, because I already had the secant x plus 1 on the bottom. All right, so this would give me secant x plus 1 plus secant x minus 1 over, and if I multiply that out on the bottom, I get secant squared x minus 1. So on the top, that gives me 2 secant x over secant squared minus 1. Oh, wait. Is that an identity? That one right there? Is that tangent? Oh, yes. I think it is. Is that tangent squared? Awesome. Okay, so now let's see. Now we're still trying to get there. I see the 2, so I'm thinking it's A now, but not 100% sold on that. So can we, let's just write them all as sine and cosine. So this would be 2 times 1 over cosine. This would be, oops, I forgot the x here. This would be sine squared x over cosine squared x. All right, let's see. So this is 2 over cosine x times the reciprocal of that, cosine squared x over sine squared x. So that's 2 cosine x over sine squared, because one of those cosines cancel out. Let's see, we're getting closer, but we need to get that to be cotangent and cosecant. Oh, I see it. That would be 2 cosine x. And if we write sine squared as sine x over sine x, then you can notice that this piece would be our cotangent. And then, of course, 1 over sine would be our cosecant. So that gives me 2 cotangent cosecant x. So this is choice A. Okay, so example 5, we have, let's see, 2 different sides here. Ooh, they both kind of look complicated. So you have to give it some thought and try to figure out which side you want to work on. My first thought would be to work on this side because it's 2 terms where the other is like down to 1, you know, all multiplied together. But I'm starting to recognize that these 2 is just another way of writing 1, because we would have sine squared theta, cosine theta, and this would be 1 over cosine theta. So these 2 would cancel out. So it just leaves me sine squared on this side, which if we use our identities, Pythagorean identities, we know this is 1 minus cosine squared. So this is the same thing as that, so we're done. Okay, so example 6, let's see. It says the extra terms in the denominator of the left expression makes it more complicated, because they both look complicated, that's sure. But this one is more because the denominator has more than one term. So let's see, we're going to have cosine t over 1 minus sine t. And notice that we can't write it in sines and cosine, in terms of sine and cosine, because it already is. There's nothing we can cancel. There's no identity we can throw in here to simplify. So that means we're going to have to multiply this by the conjugate of the denominator. That's like one of the tricks you have to kind of use. Multiply by the conjugate in order to manipulate it. Because remember, this is just an expression of 1. This is just 1. So this gives me cosine t times 1 plus sine t. On the bottom, if I multiply that, I get 1 minus sine squared t. Let's see. Oh, pay attention to your identities. Remember this on the bottom, 1 minus sine squared? That would be cosine squared t. And on the top, I've got this. So one of my cosines cancel out. So I get 1 plus sine t on the top. On the bottom, I've got a cosine t, which is exactly where we need to go because that's what the other side is. So sometimes you have to manipulate it with a clever form of 1. This is a conjugate right there. All right, so let's look at example 7. I'm thinking this side is more complicated, obviously, right? Let's see, what can we do? I can either add these together by getting a common denominator, which should work, but I'm noticing that this top piece right here, that is an identity, right? That's part of the Pythagorean identities. So let's see if I replace that part. So I have 1 minus, let's see, sine squared would be 1 minus cosine squared. All right, let's see. So that's what we would have. And, oh, I can factor that numerator, right? This would be 1 plus cosine x and 1 minus cosine x. And there are different methods you can use. You don't necessarily have to choose the ones that I did. You may not even recognize the ones that I did, and that's okay. If you're math legal, it should get you there. So now we have 1 minus cosine x, which is 1 minus 1 plus cosine x, which is just cosine x, which is where we need to be because that's what the other side is. Awesome. All right, example 8, let's see. We have 2 terms on one side, 1 on the other, so I'm thinking work on the left, okay? So we have cosecant. Let's see, we can write that as 1 over sine. Now I probably need to get a common denominator and add these together. Remember, this is like over 1. So this would be, let's see, first fraction stays the same. Second fraction, I need to get sine on the bottom. So if I multiply by sine on the bottom, I got to multiply by sine on the top. So that means I have 1 minus sine squared theta over sine theta. And, oh, that's an identity. So that's cosine squared over sine theta. Oh, we're getting closer. Look to where we need to go. Cotangent, cosine. I can see that because I can write this as cosine theta times cosine theta over sine theta. So that means this part is going to be our cotangent theta. And then, of course, the other one is just cosine, and that's exactly where we need to go. So we're done. Awesome. Now let's see, example 9. I'm thinking this side is probably more complicated because of the addition. So let's see if we can work with that. So let's see, secant squared. Secant squared. We can use an identity potentially, or we can do the reciprocal of these. Let's see, this would be 1 over cosine squared This would be 1 over sine squared. So if we add these together, getting a common denominator would be cosine squared times sine squared. So let's see, first fraction, we'd have to multiply by sine squared. Second fraction, I got to multiply by cosine squared. And that's an identity that I know. That's 1 over cosine squared sine squared. And then if I reciprocal both of these, I'm going to get where I needed to go. So sine squared x, cosecant squared x. Voila. That is what I have over here, and that's what I need. Very good.